Welcome. We are now going to look at the selected properties of Earth's atmosphere diagram in the Earth Science Reference Table. There is a tremendous amount of free information provided to us on this chart. It's just up to us to figure out how to use it. So, focusing on the info they're providing us with, first I'm going to look at the altitude arrow increasing up the left-hand side of the diagram. You'll notice that sea level is marked at 0. 0 always represents the surface of the Earth. We've got kilometers going up the left-hand side, miles going up the right-hand side. It's very important to note the difference in the values of each of the tick marks on these scales. For example, looking at the kilometer side, if this is 0 and this is 40, then each of these tick marks has a value of 10 kilometers. On the right-hand side, where we find miles, if this is 0 and this is 25, then each of these tick marks has a value of 5 miles. Please keep that in mind when answering questions related to altitude in either kilometers or miles. Now, the additional information provided here, probably most importantly, they give us the 4 layers of the Earth's atmosphere, starting with the troposphere, the lowest layer of the Earth's atmosphere, then the stratosphere, the mesosphere, and the thermosphere. You'll notice that in between we have dashed lines representing the pauses. The sphere itself is the actual layer of the atmosphere. The pause is the boundary or the interface between the layers. It marks where one layer ends and the next layer begins. So here on this section of the chart, we are looking at temperature in degrees Celsius. You'll notice the temperature data is plotted on a curve that is very zigzaggy, if you will. In the troposphere, the temperature at the surface of the Earth is 15 degrees Celsius. As we move up through the troposphere, the temperature decreases to a value of negative 55 degrees Celsius. Then it flip-flops. The temperature relationship changes. As we go through the stratosphere, starting here at negative 55, up through the stratosphere, the temperature increases to a value of 0 degrees. Then, once we hit the stratopause, the temperature once again changes, the relationship changes, and as we go up through the mesosphere, the temperature decreases with a final flip. As we go up through the thermosphere, it increases. The temperature values are very clearly marked at the different boundaries, and it's just a matter of dropping down on the dashed line to get the actual value. So, again, I'm going to erase all of this just to clean it up for future reference. This brings us to the pressure portion in ATMs, or atmospheres. Here we've got the different values of atmospheric pressure as we go up through the layers of the atmosphere. You'll notice here that the pressure relationship is indeed a decreasing or indirect inverse relationship, with the greatest pressure value being at sea level on the surface of the Earth, with a pressure of 1.0 atmospheres, and as we increase, the pressure decreases all the way up through the layers of the atmosphere. Finally, last but not least, we've got the water vapor content. Keep in mind that even though the words water vapor sit here, it looks like they're in the stratosphere. This is really just where they decided to put the title water vapor. The concentration of water vapor is actually plotted along this curve, and you'll see that the overwhelming majority of the water vapor sits in this layer of the atmosphere, which is indeed the troposphere. Please do not be misled by the fact that the words water vapor are sitting here in the stratosphere. The concentration is always referred to in grams per cubic meter, and you can see that the concentration of water vapor, again, is definitely predominantly found in the troposphere. So let's look at some sample questions that you might be asked referring to this chart in the reference table. An example question like this: an air temperature of 95 degrees Celsius most often exists in which layer of the atmosphere? So let's see, 95 degrees Celsius in which layer of the atmosphere? Back to my reference table. Just going to clean it up. 95 degrees Celsius. Let's see. If this is my temperature chart, and this value is 0, this value is 100, then 95 is probably, just freehanding it, give or take here, it crashes into my temperature curve right about there, which is definitely, without any doubt, it found in the thermosphere. So when I bounce back to my choices for that question, I need to definitely go with the thermosphere. Another example of a type of question related to this chart: at what approximate altitude in the atmosphere can stratospheric ozone be found? So let's see, I'm going to be in the stratosphere, and you'll notice that all of my answers are in kilometers. So stratospheric ozone in kilometers, let's see. Well, my stratosphere goes from here to here. When I carry those dashed lines over to my altitude scale, remember, kilometers is on the left-hand side. Each of the little tick marks is going by tens. It puts me somewhere between, let's see, about 12 kilometers and, let's see, maybe about 50 kilometers. Somewhere in this range would put me right in the middle of the stratosphere. So between 12 and 50, when I look at my choices, between 12 and 50, there's only one choice. 30 kilometers would be the best way to go. Let's sneak a peek at just one more sample question. In which two temperature zones of the atmosphere does the temperature increase with increasing altitude? So we want an increase in temperature as we go up in altitude. Back to my reference table, cleaning it up just so that we can look at a clean slate. They want to know in which two layers of the atmosphere I would find increasing temperatures. Well, let's see. This is my temperature curve, just highlighting the entire thing. And they want to know in which two layers the temperature is indeed increasing. So let's see. It looks to me like as I go up through my troposphere, my temperature is decreasing. However, when I go up through my stratosphere, it is definitely increasing. Back to my mesopause, the temperature chart is decreasing once again. And finally, up through the thermosphere, it is indeed increasing. So I'm definitely going to go with thermosphere, where I have an increasing temperature relationship, and stratosphere, where I have yet again another increasing temperature relationship. Looking at my choices, I am looking for stratosphere and thermosphere. Stratosphere and thermosphere, voila, choice C. So again, these are just a couple of examples of the types of questions you might need to look at when dealing with this chart in the reference table. I hope you have found this review helpful. Thank you.